Starting our first topic, which is circular motion. Now, circular motion is a very small topic if you look at it through the syllabus. See, it's just these 2 points. Uniform circular motion, centripetal acceleration. But the questions, when you start doing the questions, you will see a lot of in-depth concepts, right? So let's try to go over them as quicker and shortest way as possible. So starting with some basic formulas. Number one, we have angular displacement. Okay, just like in linear motion, we used to have linear displacement, linear speed, linear velocity. What does linear mean? Linear means straight line motion. So just like in AS, when we were doing straight line motion kinematics, we used to have simple displacement, speed, acceleration. Similarly, in circular motion, displacement is called angular displacement. It is going to be an angle. The unit for angular displacement is radians. Degrees is also a unit, but the SI unit is radians. Okay, if maths is your subject, you might be already familiar with radians. Now, the formula for for angular displacement is distance traveled around the circle divided by the radius of the circle. In terms of variables, you can just remember it like this. Theta equals to S upon R. Where theta is, what is theta? Theta is the angular displacement. S is the distance traveled around the circle. And R is the radius of the circle. Okay, what does it mean by distance traveled around the circle? Just to make it clear, look at this image. Now, I have an object, let's say, that starts over here at point A and then travels till point B over here. Now, what is the distance that it has traveled around the circle? This thing. You can also call it arc length. Arc length. So this is S. Okay, so we have this formula, theta equals to S upon R. This is the formula for angular displacement. Okay, next, radian. I just told you what radian is. Radian is the SI unit for angular displacement. Now, radian has a definition that usually comes in your A2 exam as a 1-mark question, right? Definitions are very marks gaining questions. So please be very good with your definitions, because definitions are is something where you can easily score marks. So the definition for radians that you should use in your A2 exam is this. 1 radian is defined as the angle subtended at the center of a circle by an arc length equal to the radius of the circle. This is the definition for 1 radian. Start by saying what radian is. It's an angle. Which angle? Angle subtended at the center of the circle when the arc length equals to the radius of the circle. This is the definition for 1 radian, right? Please use this exact definition if it comes in an exam question. Okay, now conversion. Yes, you must know how to convert between radians and degrees. If you're already a math student, you might know this, but in case you don't, here it is. If you want to convert from radians to degrees, we multiply by 180 upon pi. For example, let's say I have 2 pi radians. Okay, 2 pi radians. I want to convert it to degrees. I'm going to multiply it by 180 upon pi. Pi cancel out. So I'm left with 180 multiplied by 2, which is 360 degrees. So this means 2 pi radians equals to 360 degrees. Okay, on the other hand, if you want to convert from degrees to radians, you do the opposite. You multiply by pi upon 180. Just flip the fraction. Right, next up we have the next term, which is angular speed. Okay, now normally what is the formula for speed? It's distance upon time, right? But for angular speed, the formula will be angular distance, angular displacement upon time. What was angular displacement? We just learned it over here above. We denote it by the symbol theta. So angular speed is going to be equal to theta divided by time. And the symbol for angular speed is this. It's a Greek letter called omega. Right? Simple, nothing special to memorize over here. Linear speed is distance upon time. Angular speed is angular distance upon time. Okay, and the unit for angular speed is radians per second. Just like normally the unit for speed is meters per second, but now we don't have meters, right? Remember, we have angular displacement, which is radians. So now the unit becomes radians per second. Okay, next up is, okay, another formula for angular display, for angular velocity is omega equals to 2 pi f. This is another formula for angular velocity. Now, how did we come up with this formula? Let's look at this. Omega is equal to theta upon time, right? Angular displacement upon time. Okay, if I say that the object is completing one cycle, what does one cycle mean? One cycle means one rotation. So in one rotation, how many degrees do we have? 360 degrees. And what is 360 degrees in radians? 2 pi. So the formula now becomes 2 pi divided by capital T. Why did I make this as capital T? Because capital T in physics stands for time period. What is time period? Time period means the time taken for one complete cycle. Okay, also I hope you remember from AS and O levels, frequency is equal to 1 upon time period. So 1 upon time period, this is how it becomes 2 pi f. So now let me just write down all the formulas we have learned so far. We started with angular displacement, theta is equal to S upon R, arc length upon radius. Then we did angular speed. Angular speed is angular displacement upon time, or another formula, 2 pi upon t, or 2 pi f. But, hold on. These two formulas only apply if the time period, if it's one complete cycle. But it's not exactly necessary to be one complete cycle, because maybe the question might give you the number of cycles. Let's say the question says the time period is, they let's say give you the time period. The time period is, let's say 6 seconds. Right? So you can use this formula if you are given time period or frequency. Okay, so we are now done with some basic terminologies. Angular speed, angular displacement. Now let's have a little revision from O levels. In O levels, you have done circular motion. It was just one small little topic. Now in O levels, you were taught about directions and how to represent velocity and force and acceleration in a circular path. Velocity always acts perpendicular to the radius. In other words, it acts as a tangent to the circle. But hold on, which velocity am I talking about? It's v. It's not omega, all right? V means linear velocity, not angular velocity. Linear velocity's direction is a tangent to the circle. If you don't know what a tangent is simply, for example, this is the radius of the circle. It's a line that is always perpendicular to the radius. This is the tangent. So at any point, linear velocity is going to be a tangent. For example, at this point, see, this is how linear velocity is. At point B, it's like this. At point C, it's like this. Now notice at every point, the direction of this linear velocity is changing. It's not the same. It's going to be different at every point. This means that in circular motion, velocity, linear velocity is always changing. Because velocity is a vector quantity, meaning it has both magnitude and direction. So even if the magnitude is same, the direction isn't, right? It's changing at every point, as you can see in the diagram. So if the direction is changing, velocity is changing, right? So that's why in circular motion, velocity is always changing. It's never constant. All right. So this is the direction of linear velocity. Next, direction of centripetal acceleration. It's always along the radius towards the center of the circle. Similarly, centripetal force is also always towards the center of the circle. Now notice this means that acceleration and velocity are always perpendicular to each other. Because what did I tell you? Velocity is a tangent. Acceleration is always along the radius. So this means velocity and acceleration are always perpendicular to each other in circular motion. Okay, now I have a short little question, which was, yeah, it was a past paper question. It was just for 2 marks. Yep, 2 marks. In terms of velocity and acceleration, describe uniform circular motion of an object. In terms of velocity and acceleration, you are supposed to describe uniform circular motion of an object. What do you think? You can say out loud the answer or you can type it, whatever you're comfortable with. Anything. Yeah, are you guys there? I'm waiting for something, an answer.
Miss, when they say acceleration, do they mean the centripetal acceleration?
Yes, because they're talking about circular motion, right? So yes. Any ideas, Basam? How would you answer this question for 2 marks? Come on, guys, quick, anything, any response is fine. It doesn't matter if it's right or not. But I need an
The
interactive
velocity,
session. Yeah, yeah.
the velocity changes continuously because its direction changes,
Okay.
even though the speed is constant, and the acceleration is always directed towards the center of the circuit.
All right. Acceleration is always towards the center of the circle, and velocity is always changing because of its direction. Hmm. Both points are correct, absolutely. But you might get, wait, what did you say? You said velocity is changing and acceleration
Changing,
is
always directed towards the center of the
towards the
circuit.
center. Okay, you might get, yeah, you should get 1 mark on this. It's because notice a keyword over here. The question said describe uniform circular motion. In A-level questions, always look at minute details in questions. Uniform, what does uniform mean? Uniform means constant, right? Constant circular motion. So you need to include a reason that points out to uniform as well. So your answer should be something like this. Velocity and acceleration both have constant magnitude. That's what makes it uniform circular motion. This was the point that you're missing. And in the second point, you can mention directions. Velocity is perpendicular to, you mentioned the direction of acceleration only. You said that acceleration is towards the center of the circle, correct. But also mention the direction of velocity. Okay, do not say that it's a tangent to the circle because tangent is actually a mathematical word, right? This is physics. So instead, say that velocity is perpendicular to acceleration. This is your
Got it.
exact answer that will give you 2 marks. Here is the marking scheme. See, 1 mark for mentioning that they both have constant magnitudes, velocity and acceleration. And in the second point, you can mention directions. Velocity is perpendicular to acceleration, and you can further add that acceleration is towards the center of the circle. I hope it's clear, Basam.
Yes.
All right, perfect. So, right, this was a little basic introduction on circular motion. Next up, moving on to the new formulas. Now, these are two relationships that you just need to remember. There is no derivation for it that you need to know. Just remember these two formulas. S is equal to r theta. What is S? Arc length. What is R? Radius. And what was theta? Angular displacement. Similarly, you have another relationship. V is equal to omega r. What is V? V is linear velocity. What is omega? Omega is angular velocity. If you notice, both of these relationships are very similar. On the left side, you have linear displacement, S, linear velocity, V. On the right side, you have an R, and angular displacement, angular velocity. So let's add up over here in the formula list. We have these two relationships. S is equal to R theta. V is equal to R omega. Okay, these relationships will help you solve questions. Hmm, right now, let's move on towards circular motion, centripetal force, and centripetal acceleration. Now, there are a few formulas for centripetal acceleration. The first one is this: A is equal to V square upon R. Again, there is no derivation for this formula needed for your A2 level. You just need to memorize the formula as is. This formula is for centripetal acceleration, V square divided by R. Okay. Now, we have a few more formulas for centripetal acceleration as well, but that you can derive using the first formula. Now, instead of V, let's substitute V is equal to R omega. Remember, I just introduced this relationship to you. V is equal to R omega. So instead of V, let me substitute R omega, don't forget the whole square, divided by R. Simplify this, please. R square, omega square upon R cancel out. What are you left with? R omega square. This is another formula for centripetal acceleration. Similarly, you have a third possible formula for centripetal acceleration also. This time, you substitute for the denominator R. R is equal to V upon omega. Where did I get this from? From the same formula. V is equal to R omega. It is just rearranged. Okay, simplify, simplify, and you get this. So now this means in total, you have three possible formulas for centripetal acceleration. They are highlighted in green. The first one you have to memorize. The other two you can, in case you forget them, you can always quickly derive them like this. But when you practice enough, these formulas will be on your fingertips. You won't have to derive them at the end of the day. If you have enough practice, with practice, these will be memorized by you. They will be on your fingertips. These are three formulas for centripetal acceleration. Okay. Next, centripetal force. Centripetal force has the same formula, very similar formula, nothing special to memorize. See, you just need to remember F is equal to ma. Remember? Force, this is the formula for resultant force. Resultant force is equal to mass multiplied by acceleration. So if I just add m with the acceleration formulas, I will get the formula for centripetal force. For example, for the first one, it should be mv squared upon r. For the second one, mr omega square, sorry. And similarly for the third one, final one, mv omega. Got it? So now you have the formulas for centripetal acceleration and centripetal force. Okay, these were some formulas. Now, before moving towards some practice past paper questions on circular motion, I want you to understand a very fundamental concept that centripetal force, I am denoting it by FC. Okay, so whenever I write F with a little c, you should understand that I'm talking about centripetal force. So centripetal force is not a force itself. What does this mean? What did I just say? I said centripetal force is not a force on its own. This means centripetal force always needs another force. It is always coming from there is always some other force that is providing centripetal force. Now, let me give you an example. Um, this is the Earth. This is the Moon. Okay, now the Moon revolves around the Earth in a circular path. So basically, the Moon is undergoing circular motion, right? So it has a centripetal force, of course, Fc. But where is this centripetal force coming from? What is providing the centripetal force? Gravity. After circular motion, we have an in-depth topic on gravitation. So gravity is also a force, gravitational force. So I can say that in this case, centripetal force is equal to gravitational force. Let me call it Fg. Another example. Okay, this is a stone attached to a string, and I'm rotating the stone in a circular motion, right? So this is a stone attached to a string and it is rotating in a circular path. So since it is undergoing circular motion, it has centripetal force. Let's draw it Fc. But in this case, what is providing the centripetal force? It's tension. Why tension? Because the stone is attached to a string. If you remember from AS level, there was a complete topic of deformation. Whenever you have a string or a rope, there is always tension in it. So in this case, what is providing the centripetal force? It's tension. So using this fundamental concept, you can solve a lot of questions. You will be using this method to solve questions. So remember, centripetal force always is provided by some other force. I gave you two examples. These are not the only two examples. There are a lot of other possibilities. Another possibility is centripetal force can also be provided by a component of a force. I hope you remember components. You've done it thoroughly in AS. Vertical components, perpendicular components, horizontal and vertical components, cos theta, sine theta. I'm talking about those components. Right, so let's do a question to help better understand what we just learned. Okay, so I've opened the entire question like this. Please go over the question. I mean, just have a look at the question, then I'll move on towards explaining the solution. But I want you to first please read it out. Let me know when you're done.
Done.
Okay. All right, one more thing, guys. This meeting will end in 2 minutes. So I'll send another link in the group. Please join using that other link as soon as possible. Okay. I hope you guys have read the question. So the question is, by resolving the reaction force R into two perpendicular components, show that the resultant force acting on the ball is given by the expression W is equal to F tan theta. 2 marks. So this is like a little derivation question. and they've given you a big hint in the beginning. They said you have to resolve the reaction force into two perpendicular components. Let's do that first. I hope you remember your components. So this is one component for R. This is the other component. This one's R cos theta. This one's R sine theta. I hope there is no confusion in telling which one is cos theta or sine theta, because I'm assuming this is an AS level concept. If there is, please let me know. At any point, if there is anything that you guys maybe don't remember from AS or a concept that you guys forgot, always let me know. So I hope you guys know the component thing. This is clear.
Yes, miss.
All right, perfect. So I just drew the components. Now what? I need to somehow come up with this. W equals to F tan theta. What is W? Let's identify all the forces. W is the weight of the ball. F, what is F? What is F? Here it is. It says F is the resultant force. Meaning, in other words, F is the centripetal force, right? How do I know it's the centripetal force? Because in circular motion, the resultant force is the centripetal force. Okay, in circular motion, the centripetal force is the resultant force, right? So this is the centripetal force. All right. Remember, I just told you that centripetal force always is provided by some force, like it's either equal to gravitational force or tension. In this case, what do you think is providing the centripetal force? There is no gravity, of course. There is no rope or string, so there is no tension. Then what is providing the centripetal force? See, visualize the entire bowl. This is the bowl. The ball is moving in this sort of horizontal circular motion. So whatever is providing the centripetal force, it must be acting towards the center of the circle. Which force is acting towards the center of the circle?
The
R
normal
cos
reaction.
theta, not not the normal, the cos component of the normal. Okay, no, not R, the cos component of R. Okay, guys. So I was saying that no, it's not just R. R cos theta, the horizontal component of R, is responsible for providing the centripetal force. How do I know that? See, where is the center of the circle? If you look at the bigger picture, this one, look at this bigger picture. Where is the center of the circle? It's over here, somewhere over here, right? If this is the circular path, the center of the circle is over here. So r cos theta is exactly pointing towards the center of the circle. So r cos theta is responsible for providing centripetal force. Got it? So I'm going to, let me write it down like this. Fc, centripetal force, equals to r cos theta. Okay. But I need to somehow bring W into my equation and then tan as well. What?
Miss,
Yes.
I'm sorry, but in the figure, it seems like R is the one that's acting directly towards the center.
Hmm. See, R is a reaction force. And if you remember, what are reaction forces? Reaction forces are always act perpendicular to where the object is. So for example, the object over here is at this point, right? Let me maybe erase all of this. This is the surface where the ball is. So this is the reaction force. Okay. Now let me draw a bigger picture. Let me extend the ball maybe like this. Sorry, it's not a perfect circle, something like this. Okay. Now, the center of the circle is, let's not make it that big, maybe just like this, a semicircle. This is a horizontal circular path. Do you see? It's like a horizontal circular path. The center of the circle would be something like this, over here, roughly speaking. So what is exactly pointing towards the center of the circle? This or this arrow?
R cos theta.
It's r cos theta, because r cos theta is going to be horizontal at every point, right? The direction of r cos theta is not going to change. It will remain horizontal. But r is changing at every point. Now let me say when the ball is over here, the direction of r will be something like this. When the ball is over here, the direction is now horizontal. But the horizontal component will always remain horizontal. So that's why we took r cos theta as centripetal force. Does it make sense?
Oh, yes.
All right. Okay. So here we are, F is equal to r cos theta, but we have a problem. We do not have W, but we need to somehow include W in our equation and tan as well. So this means we need to incorporate W as well. Just like you constructed an equation for centripetal force, similarly, you can construct another equation. Notice, is the ball moving vertically? It's not. I mean, the ball is just moving in a circular path. There is no vertical movement. There is no movement just in the vertical direction. So this means that in the vertical direction, resultant force is zero. Zero resultant force means the forces in the vertical direction must be balanced. So can I say r sine theta equals to W? How is r sine theta equals to W? Because in the vertical direction, the forces are balanced. How do I know that? Because of course there is no vertical movement. The ball is not moving just vertically, is it? It's not. So the resultant force in the vertical direction is zero, meaning balanced forces. So I got another equation, r sine theta equals to W. Is it clear how we got both of them?
Yes, miss.
All right. So this is, if you are able to get these two equations, you're pretty much done. The next step is just maths. See, if you do you remember a trigonometric formula, sine upon cos is tan? Do you guys know this formula?
Yeah, yeah, we just do r sin theta upon r cos theta is equals to weight
Yes.
upon force.
Basically divide the two equations. Absolutely. Absolutely. So if I do this, see, W upon force equals to r sine theta upon r cos theta, r cancel out, sine upon cos becomes tan, W upon F equals to tan theta, and just rearrange, W equals to F tan theta. Got it?
Yes.
Perfect. So these sort of derivation questions, you always have to look at the question, think of what possibilities you can add. For example, we first came up with the first equation, but we saw that it wasn't enough because we need to somehow incorporate W in our equation. So then you thought, what can we do to add W? So you saw that maybe W is in the vertical direction. Forces are balanced in the vertical direction. You got r sine theta in that way. And then this helps you see that, okay, sine upon cos is tan, the dots connect. And then you can move on towards the mathematical part. Right, moving on. Next part, please. 1 mark. State the significance of the force F for the motion of the ball in the bowl. Significance of force F. What was F? F was the centripetal force or the resultant force. Hmm. What do they mean by significance? Significance means, importance. Importance in the
It
guard of what? In the guard of the motion.
it provides a centripetal force.
Very good. Absolutely. It provides the centripetal force required to move the ball in the circular path. Correct. This was the keyword. All right. Next up. Yeah. The ball moves in a circular path of radius 14 centimeter. We have the radius. For the radius, the angle is 28 degrees. Calculate the speed of the ball. Okay, notice they just said speed, not angular speed. So they're talking about V. What to do? You just have radius and you just have angle, nothing else. Just radius and angle. There is no other information. First, maybe think of it, is there any formula that can just directly give us? Also, always quickly look at the marks of the question. It's for 3 marks. So it's quite clear that it's not a very straightforward formula substitution question. You have to do some critical thinking. That's why it's for 3 marks. But still, let's look at all the formulas we've learned. We need to find V and we are given R and theta. There is no direct formula that can just give you V based on R and theta, right? So what to do? Let's go up. We did have a few of these two formulas that we constructed on our own in the question above. And this one too, you can use, in this is part B of the same question. So whatever formulas or expressions that were given to you in the previous parts, you can use them in the later parts. So maybe some of these questions, some of these equations. W, do we have the mass of the ball? Nope, no mass given. This was actually a simple yet slightly a question that just required a little thinking. See, I'm going to use this formula. W is equal to F tan theta. W is equal to, wait, W equals to F tan theta. Theta is not a problem. We have it. W, what is W in the question? It's the weight, but I don't know the mass nor the weight. So maybe let me for now just write mg. Okay. What is the centripetal force? We also don't know the value for the centripetal force. So maybe let me substitute a formula for centripetal force. Let's go back to the formulas in case you don't remember them. These were all the formulas. Let me use this one because this is the formula that has V in it and R also. So mv square upon R tan theta. Do you see? I hope you know that we are almost done with the question. M cancel out. You don't even need M. G, we know the value for G. It's same 9.81. V is what we are finding. R is given 14 centimeters, but please convert it to meters because look at the unit in the final answer. It is not in centimeters per second, it's in meters per second. So 0.14 and tan 28 degrees. Done. So after solving, you will get the answer. Clear? It was a simple question, but it required some time. So A2 questions are quite mathematical as compared to AS. I mean, in AS, you still had a lot of theory portion. In A2, questions are quite mathematical, especially the starting topics. Later on in the syllabus, you have, like when you move towards medical physics, that is mostly theoretical. But in the beginning, mostly questions are very mathematical. Okay, now let's do one more very important and I would say a slightly difficult question. Part A, define radian. I'm leaving this. The definition is in the notes. See, it's for 2 marks. A marks gaining question. Part B. Please read out the question. Let me know when you're done.
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 All right. Make a guess for part number 1, please. First, make a guess, and then I'll explain it thoroughly. On the dotted circle of the figure, mark with the letter S the position of the stone when the glue snaps. See, I hope you understand the question. See, this is a stone. It is attached to a rod. It's glued to a rod, basically. So at some point, the glue snaps. Like the glue, the stone just gets off the rod. The glue snaps. So where do you think it will happen? Mark a position on the diagram. Make a guess.
Should be on the what do you call it? The lowest point of the circle, like
Mm,
the very bottom.
the lowest part. Okay. Okay. What do you think, Basam? Any idea?
Before the lowest part of the part, little bit in the center.
Somewhere over here?
Yes.
Left. Okay. Okay. Well, the glue should snap at the lowest part. That is the correct answer. But what is the exact reasoning behind it? There is a very in-depth mathematical reason behind it. Let me explain that reason to you. Once that reason is clear, your concepts for circular motion will get further more strong and clear. See, let's take 4 points. 12 o'clock, 6 o'clock, 3 o'clock, 9 o'clock. Let's take these 4 points. Let me start with this point at 12 o'clock. So at 12 o'clock, what are the forces acting on the glue? Number one is the weight, of course. The forces acting on the stone, the weight of the stone, which is always downwards. Anything else? Anything else? Tension. Remember, there is a rod. Wherever there is a rod or a string or a rope, there is always tension in it. And what will be the direction of tension? Downwards. How do I know it's downwards? Because tension always acts away from the object. What is the object? The stone over here. This is the stone is the object. So tension, remember, always acts away from the object. So in this case, tension and weight both are acting downwards. Okay, now let's go down to 6 o'clock. At 6 o'clock, let's draw the forces again. Weight. Weight is again downwards. Remember, weight is always downwards. And tension. Tension this time is like this, upwards. Am I right?
Yes.
Yes.
Okay. And now let's look at 3 o'clock and 9 o'clock. Tension is like this, towards the center of the circle, towards the center of the circle. And weight is again downwards. Okay, now I drew these forces on all these points. Now the purpose is, let me try to construct an equation for the resultant force. Let's start with 12 o'clock. At 12 o'clock, the resultant force, which is basically centripetal force, is equal to tension plus weight, correct? Because tension is also downwards towards the center of the circle, weight is also towards the center of the circle. So you have two forces towards the center of the circle. So the centripetal force in this case does not depend on only one force. It depends on tension and weight, both. And it's going to be added. Why added? Because tension and weight are in the same direction. Similarly, at 6 o'clock, centripetal force is now going to be equal to tension minus weight. Why minus? Because tension and weight are now in opposite directions. Okay, why did I not do W minus tension? I mean, I could have written it like this as well. Why did I say T minus W? Because the object is, we're assuming it's moving in a circular motion, right? So which force is greater? Tension must be greater. Okay, and let's go to 9 o'clock and 3 o'clock. Centripetal force is just equal to tension. Centripetal force has nothing to do with weight over here. Why? Because the weight is not even acting towards the center of the circle. I mean, it's in a completely different orientation. It's not, it's like perpendicular to the force. So we do not consider it at all. And similarly over here also, centripetal force equals to tension. Okay. Now these two are giving you different equations, 12 o'clock and 6 o'clock. So I'm going to focus on these two. What were we trying to find? We were trying to find the position at which the glue snaps. Now, the glue is most likely going to snap where the tension is maximum, where the tension between the rod and the stone is maximum, and the glue is no longer able to hold both of them together. So it all depends on tension. So let me rearrange these equations for tension. For the first one, tension is going to be equal to Fc minus weight. And for the second one, tension is going to be equal to Fc plus weight. Where is tension the most, according to these two equations? Over here, because it's plus. Tension is equal to the centripetal force plus the weight. So it's clearly maximum over here at the lowest point. Do you understand? This was a very technical reason behind it to clear your concepts. I hope it's clear.
Yes.
Perfect. Okay, now in this case, the question didn't ask you a reason or anything. They just said mark a letter. In case they say, maybe they could say explain. Explain why does the glue snap over here? Your answer should be, you can say that it's because the tension is maximum over here. And you can also include the equation for tension. You can say that it is equal to centripetal force plus weight. Okay, done. Let's do the last part of the same question. Calculate the angular speed of the stone, 4 marks. So again, there must be some critical thinking involved. See, this is part number 2 of the same question. Focus on the details of the question. Meaning, they are asking you the angular speed when the glue snaps, meaning at point S. You still have to stick to the point S. You are supposed to find the angular speed at point S. So at S, I just constructed an equation. Centripetal force is equal to tension minus weight. At S, centripetal force is equal to tension minus weight. Let's substitute formulas now. I'm supposed to find omega. So let me substitute a formula for centripetal force that includes omega, mr omega square. See, mr omega square. This is another formula for centripetal force. So mr omega square equals to, do we have the tension? Yes. See, it's given here. When the stone snaps, the tension is 18 newtons. So I have the value of the tension. And what about weight? Do we have the weight? Yes. We have the weight of the stone also, 3 newtons. 18 minus 3. Okay, M. If you have the weight of the stone, can you get the mass? Mass is 3 upon 9.81, right? Weight upon G. R, do we have the radius? Yes, I saw it somewhere. Yep, here it is, 85 centimeters. Please convert it to meters, 0.85. And finally, omega square. Solved. Question solved. Clear?
Yes, miss.
Perfect.
Yes.
All right, guys. So I will be keeping the class till here.